May 15, 1969. Mare Island Naval Shipyard, Vallejo, California, 5:47 p.m. Pacific Daylight Time. The night shift supervisor at Building Ways 3 walked the length of USS Guitarro, hull number SSN 665, a Sturgeon-class nuclear attack submarine, 92% complete, her black steel hull gleaming under mercury vapor lights that turned the evening fog into a diffuse grey glow. The air smelled of fresh paint, cutting oil, and the salt tang of San Francisco Bay mixing with diesel exhaust from the yard locomotives shuttling materials between warehouses. The supervisor carried a clipboard listing 17 work orders scheduled for completion before the weekend. He knew that Guitarro was already 6 months behind schedule and $23 million over budget. Not because of design flaws, but because of labor disputes, material shortages, and the chaos of managing dozens of subcontractors who treated the shipyard like feudal territory, each crew loyal to its foreman, none coordinating with the others. His orders, issued by the Mare Island Project Office and endorsed by the Navy's Supervisor of Shipbuilding, were to accelerate completion without compromising safety or quality. The progress reports showed steady advancement. Everything appeared routine. Then the submarine began to sink. The first indication came not as a dramatic lurch or a metallic groan, but as a subtle change in the trim of the hull, a slow downward tilt at the bow that the supervisor noticed only because he had walked this deck hundreds of times and his body registered the angle as wrong. He stopped. He looked toward the bow. The forward section of the submarine, where the sonar dome housed the massive BQQ-2 passive sonar array, sat lower in the water than it had 15 minutes earlier. Not by much. A few inches. But submarines under construction do not settle unless they are taking on water, and submarines taking on water at the pier represent catastrophic failure of watertight integrity. He ran forward, boots ringing on the non-skid deck coating, shouting for the crew, working inside the forward compartments to report their status. No response. The interior communications system, not yet fully installed, consisted of sound-powered phones connecting only some compartments, and many of the junction boxes remained unwired. He reached the forward escape trunk, a vertical tube providing access to the interior, and shouted down into the darkness. His voice echoed off steel. Someone below shouted back, words unintelligible over the background noise of welding and pneumatic tools. The bow continued to settle. Inside the submarine, in the forward torpedo room, a welder working on ventilation duct mounts noticed water pooling around his boots. He assumed it was condensation or spillage from a cooling system test. Submarines under construction always had water in odd places, leaking hoses, drainage from pressure tests, rainwater that infiltrated through open hatches. He ignored it and continued welding. The pool deepened. It spread aft, flowing along the slight downward slope of the deck. The welder's boots were submerged to the ankles when he finally looked down and realized the water was rising faster than any spill could account for. He dropped his torch, grabbed the sound-powered phone handset mounted on the bulkhead, and cranked the generator. No answer. The line was dead. He ran aft toward the nearest ladder. Water was entering the submarine through the sonar dome access hatch, a 30-inch circular opening in the bow that allowed technicians to enter the sonar sphere for equipment installation and maintenance. The hatch cover, a heavy steel disc with a rubber gasket and 8 manual dogs, had been removed earlier in the day by a civilian crew installing sonar components. The crew had left for dinner at 5 p.m., intending to return and close the hatch after their break. They had not returned. The hatch remained open, a round portal connecting the interior of the submarine to the waters of San Francisco Bay. At high tide, the waterline sat just below the lip of the opening. As the tide rose, water began to spill over the edge. A trickle at first, then a steady flow, then a cascade as the bow sank lower and the water pressure increased. Simultaneously, at the stern of the submarine, another civilian crew was conducting a ballast tank test. The test required flooding the aft ballast tanks with water to verify that the tanks held pressure and that the vents and blows functioned correctly. The crew opened the flood valves. Water from the bay poured into the aft tanks through open sea chests, exactly as designed. The tanks filled. The stern settled lower into the water. The crew, working in the engine room and focused on monitoring pressure gauges, did not notice that the bow was also sinking. They assumed the settling was normal for a ballast test. No one had informed them that the sonar dome hatch was open forward. No one had informed the sonar installation crew that a ballast test was underway aft. The two crews worked in isolation, each executing their assigned tasks, neither aware that they were flooding opposite ends of the submarine simultaneously. The physics of the situation became irreversible at 6:04 p.m. The bow, now taking on water through the open sonar hatch, sank low enough that water began entering through a second open access point, a cable penetration in the forward ballast tank that had not yet been sealed. The flow rate doubled. The submarine's trim shifted past the point where pumps could compensate. The bow sank faster. More water poured through the sonar hatch. The stern, heavy with ballast water, provided no counterbalance. The submarine began what submariners call a down angle, a slow-motion dive that, in open water, would be corrected by blowing ballast tanks and reversing the dive planes. Guitarro had no compressed air connected to her ballast system. Her dive planes were locked in the neutral position. She had no way to arrest her descent. Workers inside the submarine felt the deck tilt beneath them. Those in the forward compartments heard the sound of rushing water, a low roar echoing through the empty spaces. Panic spread in the darkness. Men scrambled toward ladders leading to escape trunks. Some made it to the upper deck. Others, deeper in the hull, found their routes blocked by rising water. The emergency lighting, not yet connected to the backup batteries, failed to activate. Men climbed through blackness, hands groping for ladder rungs, voices shouting warnings and directions that no one could hear over the noise of water and the metallic banging of loose equipment shifting as the submarine rolled. On the pier, the night shift supervisor reached a pier-mounted telephone and called the shipyard emergency center. He reported a submarine sinking at Building Ways 3. The dispatcher, skeptical, asked him to repeat the report. Submarines do not sink at the pier. They sink at sea, in combat, or during deep diving tests. They do not sink while under construction in calm water, under the care of trained shipyard personnel. The supervisor repeated the report, his voice rising. The dispatcher activated the shipyard fire brigade and damage control teams. Sirens began to wail across the yard. Guitarro settled onto the bottom of the slip at 6:22 p.m., 35 minutes after the first signs of trouble. The water depth at the pier was 37 feet. The submarine's sail, the vertical structure housing the periscopes and masts, remained above water, along with a section of the aft deck. The forward section, including the bow planes and the sonar dome, rested on mud. The hull, designed to withstand the crushing pressure of deep ocean dives, suffered no structural damage from the impact. The damage was to systems, equipment, and Navy pride. Divers entered the water within an hour, carrying underwater lights and cutting torches. Their mission was to assess damage and determine whether any personnel remained trapped inside. They found the interior flooded to a depth of 15 feet forward and 8 feet aft, with equipment floating in the murky water. Electrical panels, not yet waterproofed, had shorted out, sending sparks arcing through the flooded compartments until someone on the pier threw the main breaker. No one was trapped inside. All workers had evacuated. The only casualties were time, money, and reputation. If you are enjoying this investigation into history's hidden conflicts, please verify your subscription to the channel Cold War Chronicles. We declassify the past to understand the present. The immediate aftermath was not heroic salvage, but bureaucratic paralysis. No one wanted to take responsibility. The sonar installation crew, when located at a nearby diner, insisted they had intended to return and close the hatch. The ballast test crew insisted they had followed their written procedures exactly. The shift supervisor insisted he had not been informed of either operation. The project office insisted that coordination was the responsibility of the contractor. The contractor insisted that coordination was the responsibility of the Navy. While the arguments unfolded in conference rooms, Guitarro sat on the bottom, her interior systems soaking in salt water, her construction schedule destroyed. The salvage operation began on May 17th, after 48 hours of planning. Compressed air was pumped into the sealed compartments to displace water and provide buoyancy. Pumps were lowered through hatches to remove water from flooded spaces. Divers sealed the sonar hatch and the cable penetrations that had allowed water to enter. Slowly, as water was removed and air was added, the submarine rose. She broke the surface on May 19th, 4 days after sinking, her hull streaked with mud and rust, her interior a wreck of waterlogged equipment and corroded wiring. The Navy convened a formal investigation. The investigation board interviewed more than 100 witnesses, reviewed work schedules, inspected quality control procedures, and analyzed the command structure at Mare Island. Their findings, released in classified and unclassified versions, were devastating. Item 1. No single individual had responsibility for coordinating work activities on Guitarro. Item 2. The project office relied on contractors to self-coordinate, a system that worked only when contractors chose to communicate, which they rarely did. Item 3. Watertight integrity during construction was treated as a low priority because submarines under construction were assumed to be safe at the pier. Item 4. The sonar installation crew and the ballast test crew were employed by different contractors, reported to different supervisors, and had no procedure for checking with each other before beginning work that affected the submarine's stability. The investigation identified the immediate cause as human error, specifically the failure of the sonar crew to close the hatch before leaving for dinner. But the deeper cause was systemic. Mare Island Naval Shipyard, overburdened with construction projects and understaffed due to budget cuts, had lost control of the work environment. Contractors operated independently. Schedules slipped. Quality assurance inspections were skipped to save time. The shipyard, once a model of precision engineering, had become a chaotic assembly line where submarines were built by committee, no one in charge, everyone responsible, which meant no one responsible. The cost of the sinking was calculated in multiple ledgers. Direct salvage costs, $2 million. Repair and replacement of damaged equipment, $25 million. Schedule delay, 8 months. But the psychological cost was incalculable. Mare Island had been building submarines since 1917. The yard had produced diesel boats for World War II, nuclear boats for the Cold War, and had never lost a submarine in construction. The sinking of Guitarro broke a half-century record of competence. Morale among shipyard workers collapsed. Contractors began to leave for private sector jobs. Engineers requested transfers. The yard's reputation, built over decades, was destroyed in 35 minutes. In Washington, the Chief of Naval Operations received a summary of the investigation and ordered a fleet-wide review of construction practices at all naval shipyards. The review revealed that Mare Island was not an isolated case. Item 1. At Portsmouth Naval Shipyard, a submarine under construction had nearly flooded due to an improperly secured sea valve. Item 2. At Electric Boat in Groton, quality control inspectors reported intimidation by contractors who resented oversight. Item 3. At Newport News, schedule pressure had led to the installation of equipment that had not been tested, resulting in multiple failures during sea trials. The pattern was clear. The submarine construction program, pushed to accelerate production to counter Soviet naval expansion, had sacrificed procedural discipline for speed. Admiral Hyman Rickover, the irascible and legendary head of the Naval Reactors Program, read the reports and issued a scathing memo. He noted that the sinking of Guitarro was not a failure of technology, but a failure of management. Submarines were complex machines, requiring obsessive attention to detail, strict adherence to procedure, and accountability at every level. Mare Island had abandoned those principles. The contractors had been allowed to operate without supervision. The project office had become a paper-shuffling bureaucracy that tracked schedules but did not enforce standards. Rickover demanded immediate reforms. He demanded that every contractor working on nuclear submarines be subject to direct Navy oversight. He demanded that shipyard commanders be held personally accountable for construction failures. And he demanded that any shipyard that could not meet his standards be shut down. The reforms were implemented slowly, resisted by contractors who saw them as intrusive, by shipyard commanders who saw them as insulting, and by budget officers who saw them as expensive. But the sinking of Guitarro had created a political environment where resistance was impossible. Congress, already skeptical of cost overruns in defense programs, demanded accountability. The press, delighted by a story combining incompetence and expensive hardware, published detailed accounts of the sinking, complete with diagrams showing the open hatch and the flooded compartments. The Navy, embarrassed, could not refuse reform. Guitarro herself was eventually repaired, commissioned in September 1972, and served for 20 years without major incident. She conducted Cold War deterrent patrols, tracked Soviet submarines, and participated in intelligence-gathering operations that remain classified. Her crew never fully escaped the stigma of serving on the boat that sank at the pier. Other submariners called her the Guitarro Hilton, implying that her crew had it easy because they had already survived the worst thing that could happen to a submarine. The jokes were bitter. The crew understood that the sinking was not their fault, but the stain remained. The broader question haunted the Navy for years. If a submarine could sink at the pier due to lack of coordination, what other failures were lurking in the construction pipeline? How many submarines were being delivered with hidden defects because inspectors were overworked or intimidated? How many safety procedures were being ignored because schedules demanded speed? The investigation into Guitarro opened a door the Navy had preferred to keep closed, revealing a construction system that was fragile, disorganized, and vulnerable to cascading failures. The answer was not comforting. Mare Island was not an outlier. The entire submarine construction enterprise, stretched thin by Cold War demands, was operating on the edge of chaos. And chaos, as Guitarro proved, was only 35 minutes away. The chaos revealed by Guitarro's sinking was not confined to Mare Island. The Navy's fleet-wide review, conducted between June and December 1969, documented a pattern of failures that suggested the submarine construction program had outgrown the institutional capacity to manage it. The review teams visited every active submarine construction facility in the United States, Mare Island in California, Portsmouth, Naval Shipyard in New Hampshire, Electric Boat in Groton, Connecticut, and Newport News Shipbuilding in Virginia. At each location, investigators found variations of the same dysfunction that had sunk Guitarro. Contractors worked without coordination. Project offices tracked paperwork but not actual work. Quality control inspectors were overwhelmed by the volume of systems requiring certification. And underlying all of it was schedule pressure, the relentless demand to deliver submarines faster to counter a Soviet naval buildup that intelligence assessments described as existential. The Soviet threat was real, but the American response had created its own crisis. Between 1965 and 1970, the United States Navy commissioned 37 nuclear submarines, an average of more than 7 per year. Each submarine required approximately 4 years to build, from keel laying to commissioning, which meant that at any given moment, more than 24 submarines were under construction simultaneously across 4 shipyards. The workforce required to sustain that pace exceeded 50,000 people. Welders, electricians, pipe fitters, reactor technicians, quality inspectors, engineers, and administrators. Many were civilians employed by contractors. Many were young, hired rapidly to meet production quotas, and trained on the job rather than in formal apprenticeships. The older generation of shipyard workers, men who had built World War II submarines and learned their trade through years of experience, were retiring or dying, taking with them institutional knowledge that could not be replaced by training manuals. Mare Island exemplified the demographic problem. In 1945, the yard employed 12,000 workers, most of them veterans of pre-war apprenticeship programs. By 1969, the workforce had grown to 18,000, but fewer than 3,000 had more than 10 years of experience. The rest were recent hires, many of them drawn from the agricultural Central Valley or from communities with no shipbuilding tradition. They learned to weld by welding. They learned to read blueprints by making mistakes. The quality of their work varied wildly. Some took pride in precision. Others simply wanted a paycheck and performed the minimum required to pass inspection, assuming inspections actually occurred. The inspection process itself had been corrupted by schedule pressure. Quality assurance inspectors at Mare Island were responsible for certifying that work met Navy specifications before contractors moved to the next phase of construction. In theory, no work proceeded until the previous work had been inspected and approved. In practice, contractors routinely began new work before inspections were complete because waiting for inspectors caused delays, and delays triggered financial penalties written into contracts. The inspectors, understaffed and overworked, often signed off on work they had not personally examined, relying on contractor self-reports. The system assumed honesty. Guitarro proved that assumption was fatal. The specific failures documented during the fleet-wide review read like a catalogue of near misses. At Portsmouth Naval Shipyard, a submarine under construction had suffered a minor flooding incident when a sea valve, supposed to be closed and locked during pierside work, was found open during a routine inspection. Water had entered the valve and flooded a pump room before being discovered. The investigation revealed that the valve had been opened by a contractor performing a pressure test and had not been closed because the contractor assumed someone else would close it. No one did. The flooding was contained, but only because a watchstander happened to notice water in a bilge that should have been dry. At Electric Boat, quality control inspectors reported that contractors had installed reactor components without the required radiation shielding because the shielding materials had not arrived on schedule. The contractors, unwilling to halt work and trigger schedule delays, installed the components anyway, intending to add shielding later. The inspectors discovered the omission during a random walkthrough. The reactor had to be partially disassembled, the shielding installed, and the components reinstalled. The rework cost 6 weeks and $1.2 million. The contractor faced no penalty because the contract allowed for schedule adjustments due to material shortages. At Newport News, investigators found that electrical panels on a newly commissioned submarine had failed during sea trials because the panels had been installed without proper waterproofing. The contractor had used commercial-grade sealant instead of military-grade sealant specified in the blueprints. The commercial sealant degraded in salt water. The panels shorted out. The submarine lost power to critical systems and had to return to port under emergency diesel propulsion. The contractor claimed the substitution was standard practice and that military-grade sealant was unnecessarily expensive. The Navy disagreed. The contractor was fined, but the submarine still required months of rework. The pattern was systemic. Contractors cut corners to save time and money. Inspectors, overwhelmed, missed the shortcuts. Problems were discovered late, often during sea trials, or, worse, during operational deployments. And the cost of fixing problems after the fact vastly exceeded the cost of doing the work correctly in the first place. The Navy was paying twice, once for defective work and again for rework, while also suffering schedule delays that undermined the strategic goal of matching Soviet submarine production. Admiral Rickover's response was characteristically blunt. In a meeting with the Chief of Naval Operations and the Secretary of the Navy, he stated that the submarine construction program was on the verge of collapse. He argued that the Navy had prioritized quantity over quality and that the result was a fleet of submarines with hidden defects that would reveal themselves at the worst possible moments. He cited Guitarro as proof that the system could not be trusted. He demanded that every submarine under construction be subjected to a full inspection, that any submarine found to have defects be taken out of service until repaired, and that contractors failing to meet standards be barred from future Navy work. The proposal was politically and financially impossible. A full inspection of every submarine under construction would halt production for months. Taking defective submarines out of service would reduce the operational fleet at a time when Soviet submarine activity was increasing. Barring contractors from future work would leave the Navy with insufficient shipyard capacity to meet construction goals. The proposal was rejected. Instead, the Navy implemented a compromise: enhanced oversight, mandatory quality checks at key milestones, and financial penalties for contractors who failed inspections. The reforms were real, but incremental. They addressed symptoms, not causes. The deeper cause was economic. The United States was fighting a war in Vietnam, funding a strategic bomber program, building a ballistic missile defense system, and maintaining a global network of military bases. The defense budget, though massive, was stretched thin. Submarine construction competed with aircraft carriers, destroyers, and fighter jets for funding. Every dollar spent on inspections and rework was a dollar not spent on building new submarines. The pressure to deliver submarines on schedule and under budget was relentless, and that pressure flowed downward through the Navy bureaucracy to the shipyards and contractors, where it manifested as shortcuts, omissions, and the kind of catastrophic negligence that sank Guitarro. Guitarro herself, meanwhile, sat in a repair dock at Mare Island, surrounded by scaffolding and flooded with harsh light from arc welders working around the clock to replace corroded systems. The sonar array, the most expensive component of the submarine, had been destroyed by saltwater immersion. The BQQ-2 sonar system cost $14 million and required 18 months to manufacture. Replacement units were not sitting in warehouses. They were custom-built to order. Mare Island had to wait. While waiting, workers replaced electrical panels, stripped and repainted corroded surfaces, tested and retested every valve and pump, and essentially rebuilt the forward third of the submarine. The crew assigned to Guitarro, officers and enlisted men who had trained for months to operate her, waited as well. They had been told the submarine would commission in January 1970, then March, then June. The delays stretched. Morale suffered. Some crew members requested transfers. Others simply accepted that they were part of the Navy's most famous embarrassment and tried to make peace with it. The commanding officer, a career submarine officer who had not been aboard during the sinking but inherited the aftermath, held weekly meetings to reassure the crew that Guitarro would be an excellent boat once repairs were complete. The reassurance rang hollow. Everyone knew that the boat's reputation was ruined before she ever went to sea. The broader institutional response to the Guitarro incident revealed fractures within the Navy's leadership. Some admirals argued that the sinking was an isolated incident caused by specific failures at Mare Island, and that systemic reforms were unnecessary. Others argued that Mare Island was a symptom of deeper problems, and that without fundamental changes, more submarines would fail in more spectacular ways. The debate played out in classified memos and tense meetings, and the resolution was predictably bureaucratic: create new oversight committees, write new procedures, and hope that the appearance of reform would prevent future disasters. But hope is not a strategy, and new procedures are meaningless if no one enforces them. The contractors who had flooded Guitarro were not fired. The project office personnel who had failed to coordinate the work were not disciplined. The shipyard commander retired on schedule with full honors. The system absorbed the failure, filed the reports, and moved on. Guitarro became a case study in training courses, a cautionary tale told to new inspectors and project managers, but the conditions that caused the sinking remained largely intact. Meanwhile, the Soviet Union watched and learned. Soviet naval intelligence had tracked the Guitarro incident through open-source reporting in American newspapers, which had gleefully published details of the sinking. The reports were translated, analyzed, and circulated among Soviet submarine designers and naval strategists. The analysis was straightforward. American submarine construction, despite its technological superiority, was vulnerable to organizational dysfunction. The Soviets, whose own submarine program suffered from chronic quality problems, took some comfort in the knowledge that even the Americans made catastrophic mistakes. But the Soviet analysis missed the crucial difference. When American submarines failed, the failures were investigated, documented, and corrected. When Soviet submarines failed, the failures were often covered up, blamed on individual scapegoats, and repeated. The Soviet system prioritized secrecy over learning. The American system, for all its flaws, prioritized transparency, at least internally. That difference, over time, compounded into a strategic advantage. American submarines improved. Soviet submarines stagnated. Guitarro eventually returned to service in September 1972, more than 3 years after her scheduled commissioning date. Her first patrol was uneventful, as were her subsequent patrols over the next 2 decades. She performed as designed. Her systems functioned reliably. Her crew, despite the stigma, operated her with professionalism. And yet the question lingered. How many other submarines carried hidden defects, installed during the same chaotic construction period, that had not yet revealed themselves? How many valves had been improperly sealed? How many welds had been inadequately inspected? How many electrical panels used substandard components? The Navy could not answer those questions without inspecting every submarine in the fleet, a task that would require years and cost billions. So the Navy did what institutions do when facing uncomfortable truths. It accepted the risk, monitored for failures, and hoped that the law of averages would favor them. The hope was not entirely unfounded. Most submarines functioned correctly most of the time. But most is not all, and most of the time is not always. And in the underwater environment where a single failure can kill everyone aboard, most is not good enough. The risk materialized in ways large and small over the following decades, validating both the fears of those who demanded reform and the complacency of those who believed the Guitarro incident was an anomaly. In 1973, USS Woodrow Wilson, a ballistic missile submarine commissioned in 1963, suffered a reactor coolant leak during a routine patrol in the Atlantic. The leak was caused by a corroded valve that had been improperly installed during construction 10 years earlier. The valve had passed initial inspections because the inspector had checked paperwork rather than physically examining the installation. The corrosion progressed slowly, invisible behind layers of insulation and shielding, until the valve failed under pressure. The crew contained the leak using emergency procedures, and the submarine returned to port without casualties. But the incident forced the Navy to inspect similar valves on every submarine in the fleet, a process that took 8 months and revealed 12 additional valves with improper installations. In 1978, USS Guitarro herself experienced a near-catastrophic failure during a training exercise off the coast of California. A seawater cooling pump, part of the reactor's secondary cooling system, seized due to a manufacturing defect in the pump bearings. The bearings had been supplied by a subcontractor who had falsified quality control certificates to avoid the expense of proper testing. The pump failure caused the reactor to overheat. The crew initiated an emergency shutdown and switched to backup cooling. The reactor was saved, but the submarine was forced to operate on limited power for 3 days while backup systems maintained safe temperatures. The investigation traced the defective bearings to a batch of components manufactured in 1969, during the height of the construction surge, and installed in multiple submarines. The Navy recalled and replaced the bearings across the fleet. In 1982, USS La Jolla, a Los Angeles-class fast-attack submarine, experienced flooding in the forward torpedo room when a torpedo tube muzzle door failed to seal properly. The door had been installed with a gasket that did not meet Navy specifications. The gasket material, supposed to withstand seawater at depth, degraded after repeated pressure cycles. The flooding was controlled before it became critical, but the submarine surfaced and returned to port. The gasket supplier, when confronted, claimed that the gaskets had met the specifications in effect at the time of manufacture, and that the Navy had changed specifications without notifying suppliers. The dispute became a legal battle that dragged on for years, during which the Navy replaced gaskets on every torpedo tube in the fleet at a cost exceeding $30 million. Each incident, taken individually, was survivable. The crews were trained, the backup systems functioned, the submarines returned safely. But each incident also represented a failure that could have been prevented if the work had been done correctly in the first place. And each incident reinforced the lesson that Guitarro had taught. The submarine construction system, stressed beyond its capacity during the Cold War buildup, had produced a fleet with latent defects that revealed themselves unpredictably, sometimes years or decades after construction. The human cost of these failures was not measured in deaths, because no American submarine was lost due to construction defects during this period. But the cost was measured in fear. Submarine crews operated with the knowledge that their boats might contain hidden flaws, that a valve might fail, a weld might crack, a component might be substandard. The fear was not paralyzing, but it was persistent, a background anxiety that every submariner learned to manage. They trusted their training, their equipment, and each other. But trust is not certainty, and the gap between the two was filled with doubt. The institutional response to these failures followed a predictable pattern. After each incident, the Navy convened an investigation, identified the root cause, implemented corrective measures, and declared the problem solved. New inspection protocols were written. New quality standards were mandated. Contractors were warned. And then the cycle repeated. The problem was not that the Navy failed to respond. The problem was that the responses addressed individual failures without fixing the underlying system that generated the failures. The underlying system was economic and cultural. Economically, the submarine construction program operated under constant budget pressure. Congress appropriated funds for a specific number of submarines per year, and the Navy was expected to deliver those submarines on schedule and within budget. Overruns were scrutinized, delays were criticized. The pressure to perform created incentives to cut corners, to accept marginal work, to defer maintenance, and to prioritize schedule over quality. Culturally, the shipyards operated under a hierarchical structure where authority was concentrated at the top and accountability was diffused throughout the organization. When something went wrong, blame flowed downward to the lowest level possible. Contractors blamed workers. Workers blamed supervisors. Supervisors blamed project offices. Project offices blamed the Navy. The Navy blamed contractors. No one accepted systemic responsibility. Admiral Rickover understood this, and his response was to centralize authority in the Naval Reactors Program, the office responsible for all nuclear propulsion systems. Rickover's office controlled the design, manufacture, installation, and operation of every reactor in the fleet. Contractors who worked on reactors answered directly to Rickover's inspectors. Quality standards were absolute. Failures were not tolerated. And the result was that reactor-related failures were extraordinarily rare. The reactor that powered Guitarro, despite the submarine's disastrous construction history, operated flawlessly for 20 years. The reactor on USS Woodrow Wilson, despite the coolant leak, never failed. Rickover's system worked because it was rigid, uncompromising, and enforced by a man who had the political power to fire contractors, overrule admirals, and demand compliance. But Rickover's authority extended only to reactors. The rest of the submarine, the hull, the sonar, the torpedoes, the electrical systems, the plumbing, was outside his jurisdiction. Those systems were managed by the traditional Navy bureaucracy, which lacked Rickover's focus and lacked his willingness to punish failure. The result was a split personality fleet, reactors that were nearly perfect, and everything else that was merely adequate. The adequacy was sufficient for peacetime operations, where submarines patrolled predictable routes, operated under controlled conditions, and had time to address problems before they became critical. But adequacy is not sufficient for wartime, where submarines operate at the limits of their capabilities, where damage control is conducted under fire, and where a single failure can mean the difference between survival and death. The Cold War never turned hot, and so the adequacy of American submarine construction was never tested under the conditions for which the submarines were designed. The Soviets, meanwhile, faced their own construction crises, but with less transparency and harsher consequences. Soviet submarines suffered catastrophic failures at a rate far exceeding American submarines. Between 1960 and 1990, the Soviet Navy lost 9 submarines to accidents, compared to 2 American submarines lost during the same period. The Soviet losses included reactor meltdowns, fires, collisions, and floodings caused by defects that would have been caught by American inspection standards. But Soviet inspection standards were lower, and Soviet accountability was punitive rather than corrective. When a Soviet submarine failed, the officers were court-martialed, the crew was reassigned, and the incident was classified. No public investigation, no systemic reform. The same mistakes repeated. The comparison between American and Soviet submarine construction reveals a fundamental difference in institutional culture. American failures were investigated openly, documented extensively, and used as lessons to improve future performance. Soviet failures were hidden, denied, and blamed on individuals rather than systems. The American approach, for all its flaws, allowed for learning and improvement. The Soviet approach ensured stagnation. Guitarro, in this context, was both a failure and a success. A failure because she sank at the pier due to inexcusable negligence. A success because the Navy investigated the sinking, published the findings, implemented reforms, and used the incident to improve shipyard practices across the fleet. The reforms were incomplete and imperfect, but they were real, and over time, they made a difference. By the 1980s, American submarine construction had stabilized, quality improved, failures decreased. The lessons of Guitarro, painful and expensive, had been absorbed, but the question remains, could the sinking have been prevented? The answer is unambiguously yes. If the sonar installation crew had closed the hatch, if the ballast test crew had coordinated with other workers, if the project office had enforced watertight integrity protocols, if the shipyard commander had insisted on centralized control, if any one of a dozen individuals had made a different decision, Guitarro would not have sunk. The failure was not inevitable. It was the result of choices, or more precisely, the result of failing to choose accountability over convenience. The legacy of USS Guitarro is not the submarine itself, which served competently for 2 decades and was decommissioned without distinction in 1992. The legacy is the revelation that even the most technologically advanced military in the world is vulnerable to organizational dysfunction. That complexity requires coordination, and that coordination requires authority, and authority requires individuals willing to accept responsibility. Guitarro sank because no one was in charge. The lesson, simple and brutal, applies beyond submarines and shipyards. It applies to any organization that prioritizes speed over process, output over quality, and appearances over reality. The submarine, raised from the mud and repaired at great expense, went to sea and did her job. The system that built her, exposed and criticized, adjusted and continued. The men who worked on her, blamed and defensive, learned or did not learn, and moved on to other projects. And the Navy, embarrassed but resilient, filed the reports, updated the manuals, and prepared for the next crisis. Because there would be a next crisis. There always is.